Welcome to converting higher order systems to first order systems. So definition, first order system is a system of n differential equations and first order differential equations in n unknown functions. Of the form y1 prime is equal to some function of x and y1 through yn, all the way through yn prime is equal to some, so I'm going to call the first one f sub 1, and yn prime is equal to a function f sub n of x and then y1 through y sub n. So notice that each derivative yi prime can be written in terms of only the original functions, not any of their derivatives. So general idea is if we have a higher order system, we can actually convert it to a first order system. So if we have higher order derivatives involved, and in this case, we're going to go with, in other words, nth order derivatives. Then what we can do is we can rename all of the lower order derivatives with new variables. So if we have higher nth order derivatives involved, then rename all of the lower derivatives of the lower order derivatives new functions. And we can actually create a first order system. So for example, let's consider the system third derivative of y1 is equal to 2y1 double prime minus 4y2 double prime plus 3y1 prime minus 2y2 prime plus 5y1 plus y2. Second equation, third derivative of y2 is equal to 3y1 double prime minus 2y1 prime plus 6y1 minus 7y2. Our job is to convert the system to a first order system. So it's up to you if you want to rename y1 and y2 as well, so that we keep the same variable name through, that's fine. So for example, we could set z1 equal to y1. And we could set z2 to be y1 prime and z3 to be y1 double prime, right? Those are all the lower order derivatives of y1. We're not going to rename the third derivative. Then let's set z4 to be y2. z5 will be y2 prime and z6 will be y2 double prime. So just note z1 prime is just y1 prime, which is z2. Similarly, z4 prime is just y2 prime, which is z5. So we can write the first derivative of z1 in terms of the other functions, z functions. We can write the first derivative of z4 in terms of the other z functions. Similarly, z2 prime is just y1 double prime, which is z3. And z5 prime is just y2 double prime, which is z6. Finally, z3 prime is just the third derivative of y1, which was the only other piece, one of y1 piece in our equation. And z6 z6 prime is just the third derivative of y2. So we can substitute these into our equations. So substituting into our equations, we wind up with the system I need to give myself a little more space. We'll have a differential equation for each. We already established the fact that z1 prime, was z2. We already established the fact that z2 prime was z3. Our z3 prime, we're going to rearrange our original equation. So our original equation, we had the third derivative of y1. Apologies, my screen is not updating. So for z3 prime, this was just our third derivative of y1. Right? And we had the equation third derivative of y1 was equal to 2y1 double prime minus 4y2 double prime. Followed by plus 3y1 prime minus 2y2 prime. Followed by plus 5y1 plus y2. And so we get z3 prime is equal to y1 double prime was our z2. No, sorry, y1 double prime was our z3. So we have 2 times z3. Y2 double prime was our z6, so minus 4z6. Then we have plus 3, y1 prime was z2, so plus 3 times z2. Minus 2, y2 prime was z5, so minus 2z5. And we have plus 5z1 plus z4. So we can rearrange that equation. We have z3 prime is equal to 5z1 plus 3z2 plus 2z3 plus z4 minus 2z5 minus 4 z6. So this was our equation for z3 prime in terms of the original functions and no derivatives. Z4 prime is just z5. Z5 prime was just z6. For z6 prime, again, we'll have to pull up our original equations. For z6 prime was just the third derivative of y2. And we had an equation for that. The third derivative of y2 was equal to, I apologize for the scrolling, 3y1 double prime minus 2y1 prime plus 6y1 minus 7. So we had 3y1 double prime minus 2y1 prime plus 6y1 minus 7y2. If I remember correctly, I'm just going to check one more time. 3y1 double prime minus 2y1 prime plus 6y1 minus 7y2. So once again, if we rename this, this is z6 prime is equal to y1 double prime was z3. So we have 3z3. Y1 prime was z2, so minus 2z2. Y1 was z1, so plus 6z1. And then y2 was z4, so minus 7z4. So rearranging this one, we have z6 prime is 6z1 minus 2z2 plus 3z3 minus 7z4. So our system, we have these 6 equations. Z1 prime is z2, z2 prime is z3, z3 prime is 5z1 plus 3z2 plus 2z3 plus z4 minus 2z5 minus 4z6. Z4 prime is z5, z5 prime is z6, and z6 prime is 6z1 minus 2z2 plus 3z3 minus 7z4. So as you can see, we did wind up with 6 equations in 6 unknown functions. A special case of this is if we just have one differential equation in one unknown function. So in other words, what we saw in chapter 9 material. We can view this one equation as a system on its own, and we can pull the same trick. So we can convert this fourth order equation, fourth derivative of y minus 2 times the third derivative plus 7 times the second derivative minus 4y prime minus 5y equals 0 into a first order system. Again, we'll set, this time around, we'll set y1 to be y. We'll set y2 to be y prime. We'll set y3 to be the second derivative of y, and we'll set y4 to be the third derivative. Again, I'm just using the highest order of derivative was the fourth derivative, so we're just going up to the derivative before that. So in this case, note that y1 prime is just y prime, and that's therefore y2. Y2 prime is just y double prime, otherwise known as y3. And y3 prime is the third derivative, otherwise known as y4. Y4 prime is the fourth derivative of y. And based off our differential equation, that should be equal to 2 times the third derivative apologize for the scrolling, minus 7 times the second derivative plus 4 times the first plus 5y. So minus 7 times the second derivative plus 4 times the first derivative plus 5y. Again, that was equal to all, the original equation, we had everything on the left side equal to 0. I just moved the terms to the right. So what we get is that our y4 prime is equal to, the third derivative of y was just y4, so we have 2y4 minus 7 times the second derivative, which was y3, plus 4 times the first derivative, which was y2, plus 5 times y, which was y1. So we get the system y1 prime equals y2, y2 prime equals y3, y3 prime equals y4, and y4 prime is 2, well, I'm going to actually rearrange these, is 5y1 plus 4y2 minus 7y3 plus 2y4. So what we get from this is if we know how to solve a first order system, then we can solve a higher order ODE. So if we know how to solve first order systems, then we have an alternative way of solving higher order ODEs or nth order ODEs. So we have an alternative way to solve nth order ODEs. So not only are systems useful for more complicated application problems, they can also be useful just for solving higher order differential equations as well.